Hello, everyone. Greetings from New Jersey, visiting family for Thanksgiving. So what I want to do in this short video is discuss Macaulay duration and interpret it as a kind of average time that the bulk of the price of an annuity occurs at. So remember, for us, we simply defined Macaulay duration, MACD. So if we have an annuity with a yield rate of I per period, we define MACD as just 1 plus I times the modified duration. And remember, the modified duration is just minus the relative rate of change of price with respect to yield rates. Okay. And we just stick a minus here because the relative rate of change for all practical examples is negative. So we just stick a minus here to make this positive. Okay, so let me show you something else here. So I'm at Investopedia, excellent website for anything finance related. And so this is their Macaulay duration kind of web page. And you'll see that they describe Macaulay duration as sort of an economic balance point of a group of cash flows. And if you go to other financial websites, you'll see Macaulay duration sort of interpreted in that sense. And yes, let me discuss how we can interpret it in that way. Okay. So to do this, we really need to review some basic probability stuff. So let me, in particular, the expected value of a discrete random variable. So let me kind of do this in analogy to kind of choosing a random exam from just a group of exams taken, and let's look at the grade of that randomly chosen exam. Okay. So, and yeah, I'll connect kind of this to Macaulay duration for the price of a annuity in a moment. So let's say N is the total number. So actually, we don't really need that. So let's just say we are looking at an exam, the grade of an exam chosen at random. So it could even be in my class, AMAT 201, 301. There was a bunch of exams taken. So let's say big X, my random variable, is grade of exam chosen at random. Okay, so let's say keep this simple. The possible grades are A, B, C, D, and failure, which for us, UAlbany is E. Okay, and because it's much better to work with numbers, let's say this corresponds to 5, 4, 3, 2, and 1. So 5 corresponds to an A, and a 1 corresponds to an E. Okay. So this is in kind of probability parlay the sample space. This is kind of the set of all possible outcomes of my random variable. Okay. And again, I'm just dividing all the grades of these exams into one of these 5 categories. It's everything's either an A, B, C, D, or if it's below a D, it's considered failure. Okay, so let's say P1 is the probability, and I like to use this fancy P for probability. This looks nice. Okay, so let's say this is the probability that the grade of this exam chosen at random is a failure. Okay. So more practically, what is this? It's the number of failures the number of E's divided by total number of exams. Well, number of E's is number of ones, so I'll just replace it with 1. So let's say P2, same thing. It's probability that this randomly chosen exam has score D. So this is the number of 2's or D's over the total number of exams. What did I write? Over a total number of exams, etc. Okay. So this definitely is a probability situation in the sense that the sum of these P's, I'll write it like this, this is 1. Okay. The probability that we get either a 5, 4, 3, 2, or 1 for this randomly, the grade of this randomly chosen exam is 1. Okay, because, well, the grade is only A, B, C, D, or E. There's no other options. There are no other choices. And this sum here is exactly the probability of getting either a 1, 2, 3, 4, or 5. Okay? These are mutually exclusive. You can't get an exam with both an A and a B. It's either an A or a B. Okay. Okay. Or if you want to kind of think, if you sum all this up, basically you're going to have in the denominator the total number of exams, and the numerator is going to be the actual sum of the number of 1s, 2s, 3s, 4s, and 5s, and that is literally just the number of the total exams divided by the number of total exams. Okay. To add up these probabilities, we get 100%. So hopefully you remember, it's probably the most important concept in all of probability theory and statistics. So the expected, or really average, exam grade, move that down here. Okay, so that's mu. Doesn't matter what we call it, but remember the formula. And I think everyone has their own kind of notation here. Well, we're just running over the whole sample space, and it's x times the probability that my random variable, remember big X is the exam score of this randomly picked exam. Probability that the exam score equals X. You can write this as X PX. And another way of interpreting this, maybe a little more clear, is that this is X times, again, kind of going back like we had before, total number of X's over total number of exams. Okay, so total number of 1s, total number of 2s, etc., etc. Okay, so the idea is that you look at all these grades, and the average grade is going to be given by this formula here. Okay, so at a first glance, probably doesn't seem like there's any kind of connection to price of an annuity, but there is. There's actually a very strong connection. So let's say we have an annuity. So I'll just do payments at the end of each period. Same kind of idea will work for payments at the beginning of each period, just change notation. KT is a payment. At the end of period T. All right. Let's say a per period yield rate we have is I. Everything I do works with respect to term structure of interest rates, i.e. a table of spot rates, but just really not any, don't get anything, there's no benefit from doing that, just from trying to get interpretation of Macaulay duration. All right, so as I mentioned many times, you don't really need to memorize this formula for the total price, present value, same thing. But you better be able to kind of come up with it very quickly. So you take the present value of all these, and let's say this is an N period annuity. So yeah, you just discount this payment by T periods. Okay. So the price of each individual payment, kind of an analogy, kind of analogous to not the total number of exams, but the number of specific grades. This is just, sorry. This is 1 plus I to the minus T. Right. Okay, so let's call PT in total analogy to kind of saying P T was a number of, or PX was a number of X's over the total number of exams, X being 5, 4, 3, 2, or 1. Let's say PT is, and one thing I want to make clear before I do anything else, another way of thinking of this, PX, is the ratio of X's to the total number of exams. That's one very nice way of thinking about PX. It's the ratio of X's, ratio of ones to the total number of exams, ratio of twos to the total number of exams, et cetera, et cetera. Okay. So same kind of thing. Let's say PT is the price of payment. And I want to use T because usually the formula of Macaulay duration is T, with respect to T. Okay, so this, just plop in my formulas. And I already have T here, so I'll just use X, I guess. Doesn't matter what variable I use. Okay, and the way you should really think of this is just kind of like we had before. It's the ratio of the payment KT to the total price. So before we had the ratio of the X's to the total number of exams. This is the ratio of the payment K to the total price. All right, so we're definitely in the probability situation. So this is equal to 1. You can see that very easily. You sum this up. Just pull the denominator out. And you're just going to get the total price over the total price. In some sense, you can think of the sample space as being t equals 1, t equals 2, all the way to t equals n. You don't really quite have a random variable floating around that I could really think of, but still, kind of pushing this analogy further, you can kind of think the average expected time using the same formula as before. It'd be T PT. Now let's see what that gives me. Again, you can think of this as T times the ratio of the price of KT to the total price, an analogy of what we've done before. Well, this is going to be equal to, just plop in what we have for PT. So T KT 1 plus I to the minus T over the sum here, T equals 1 to N. And this is going to be equal to, well, lo and behold, the Macaulay duration formula we had before for the an annuity with payments of KT at the end of each period, and a yield rate, a per period yield rate of I. So I'm just taking this here and bringing it outside. This is really constant with respect to the sum here. I'm bringing it outside. Yeah, and this is the Macaulay duration. Okay. So the Macaulay duration, you can think of as kind of an average time, and it's an average time in the sense that it's really average time that the bulk of the price of the annuity occurs at. And so that's kind of why it's a reasonable thing to think of kind of the Macaulay duration as a sort of economic balance point of the group of cash flows. It's just really the expected or average time corresponding to this annuity with respect to the price of each payment. So it's like the average time that the bulk of the price of the annuity occurs at. Okay. Yeah, so hopefully that was helpful in interpreting Macaulay duration. And hopefully that makes sense as to why units of time is used often when we deal with Macaulay duration. And I would still say probably for exam FM, this is, that's a little weird. this kind of formula is really more important than anything else. But but yeah. And if you want to learn more kind of the practicalities of Macaulay duration outside of exam FM, I would definitely go to really any of these financial websites. Will kind of talk about Macaulay duration from a much more finance perspective rather than a actuarial perspective. All right. Well, hopefully this was helpful. And yeah, have a good Thanksgiving. Don't eat too much. Until next time, take care. Have a good day. Bye bye.